Taking a look at the examples page, it says that we are going to find the relative maximum or minimum points, state the end behavior, and if there is symmetry present in the graph. So taking a look at number 1, the first thing we are going to look for is maximum or minimum points. And in order to do that, all you do is you take a look at these y values. So if you notice here, from 100 to 81, it's decreasing. And then it's still decreasing, decreasing, decreasing. It's going to continue to decrease until we hit 0. Let's try it this way. There we go. It's going to go ahead and decrease until we hit 0. So if it's decreasing, 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 and then it increases again, so as soon as it goes back up from 0 back upwards, that makes this point 0, 0 a relative minimum. And as we follow the y values again on the other side, from 1 to 4 to 9 to 16, they keep increasing. So all this table of values shows us is a relative minimum there at 0, 0. Now we're going to state the end behavior. So looking at the pattern, 25, 36, 49, 64, 81, 100. So as these y values in the table go up, they are increasing. So they are going to go towards positive infinity. So writing your end behavior as x goes towards negative infinity, y goes towards positive infinity. On the other side, as looking at the x column, x keeps going up 1, 2, 3, 4, all the way to 10. So looking at the right side, as x goes towards positive infinity, how do the y values go? 0, 1, 4, 9, 16. Those are also going towards positive infinity. So this would be your end behavior as well. And let's take a look at symmetry. Symmetry is if there is mirroring going on in the table. So if there's a number above and a number below. So if we look here where 0, 0 is, we have 1 above and 1 below, and then 4 above and 4 below, and then 9 above and 9 below, 16 above, 16 below. So this is the mirroring that I'm talking about. So that means that we do have symmetry about that point 0, 0. And that is all that we can conclude with table number 1. Taking a look at table number 2. So we are looking for relative maximum, relative minimums. So from 0.08 to 0.04, this is decreasing, 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 decreasing. But from 0.003 to 0.002, this increases. So if you can picture it, if the graph is decreasing and then increasing, that means there is going to be a relative minimum right here. It is not going to be a distinct point like in number 1 because the numbers don't mirror over that point. But that does give us a relative minimum. Continuing to look at the y values, 0.05, increase, 0.09, increase, 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 increase. But from 0.18 to 0.17, right here, we would be increasing, 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 and then drop down. So this is where we would have a relative maximum. Again, we don't have a distinct point because the numbers don't mirror on top of that maximum point. But we know one is there because it goes from increasing to decreasing again. So then we're going to go and keep looking. So we've got increase, and then another decrease. So right here, we've got another increase and then decrease, which would make that another relative minimum right here. And then 0.01, it just continues to decrease. So there would not be any more relative maximums or minimums. Let's take a look at our end behavior. So as we move into smaller x values, so as x goes to negative infinity, what happens to the y values? Y goes towards, if you look at your y values, they keep increasing there towards the end. So here's where we just have to make that conclusion that y is also going to go towards positive infinity. Taking a look at the other side, so as x goes toward positive infinity, what is happening to your y values? So you're looking towards the end of that table, and we've got negative 0.41, negative 0.46, negative 0.48. So we can go ahead and conclude that those y values keep continuing to get smaller, so they go towards negative infinity. Taking a look at symmetry, when it comes to symmetry, you're looking to see if there is any mirroring in the table. So if there's any y values that match above or below a certain point. And if you look closely at the table, you can see we don't have that. So there is no mirroring going on. So make sure you've got this relative min marked right here, this relative max marked right here, and this relative min marked here as well. And then you have your end behavior. Taking a look at number 3, let's look for our relative maximums or minimums. So from negative 5.5 to 2, it's increasing. From negative 2 to 0.5, we're still increasing, increasing, increasing. But from 2.5 to 2, this is a decrease. What you should also notice right here is the mirroring that's going on within the table. So if you have a change in increase to decrease or decrease to increase, you've got a relative max or min, and the mirroring tells you that that's that relative max or min point. So we're going from increasing to decreasing. So in your head, if you're visualizing, increase to decrease means this point right here, 1, 2.5, is a relative maximum. With that relative maximum, we can also go ahead and say that there is symmetry right here as well. Okay, now we're going to take a look at our end behavior. So as x is going towards, as x is going towards negative infinity, so as we're moving up our table of values, what is happening to our f of x values? They are also getting smaller towards negative infinity. So here you want to make sure that you use f of x in your answer. Looking at the other side of the graph, as your x values get bigger, what's happening to your y values from 2.5 to 2 to 0.5, and this the negative 2 would mirror underneath, and the negative 5.5 would mirror underneath. So it would be the same thing for as x goes to positive infinity. Your f of x values are getting smaller as your x's get bigger or smaller. Okay, last example, example 4. So we're going to look for our relative maximums or minimums first. So looking at your y values, these are getting bigger, 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 bigger. And then from 20 to 12, there's a decrease. So there's going to be a maximum point in here. There is not symmetry. So we're just going to put a line right here, and that's where a relative maximum is going to be. Again, how did I get that? So from negative 780 to negative 540, all of these numbers are increasing until we get to 20, and then they decrease when x is negative 1. And then we keep going again. The y value is 12, 0, negative 10, negative 12. So these are all decreasing. But then we go from a y value of negative 12 to a y value of 0. So we just went from decreasing back up to increasing, which would make we're going from decreasing to increasing, there would be a relative minimum point right here. Continuing the pattern from 0 to 32, it's increase, 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 and then they just keep increasing from there. Okay, let's take a look and see if there's any symmetry. Well, I got negative 780. I don't see any numbers that repeat. Well, there's a 0 here and a 0 there, but they don't match in between. So there's no symmetry for the problem for table number 4. Let's take a look at end behavior. So as x goes towards negative infinity, what happens to your y1 values? So we're just going to assume it follows the same pattern at the end. So from negative 10, negative 352, negative 540, negative 780, they keep decreasing. So as the x values get smaller, so do your y1 values. So y also goes towards negative infinity. Looking at the other side, so as x goes towards positive infinity, we have to decide which way y goes. So we got 308, 480, 702, 980. That's increasing there towards the end. So we can go ahead and say as x goes to positive infinity, y also goes towards positive infinity. So after today, you should have complete notes for pages 1 through 10. If you do not have complete notes for 1 through 10, then you need to go back through and watch the Nearpods to get all those notes copied down. You have a quiz in the next class period. If you do not have your notes copied down, when it comes time to make corrections on that quiz, you cannot take corrections on your quiz.